Hello. In this video, I'm going to show you how to look at a circle graph and then pull information out of it to help you answer questions about it. Before we get there, I have a little vocab like I do in many videos, and you probably guessed that this first piece of vocabulary is talking about our circle graph. It's just a type of statistical graph used to compare parts of a whole, and the entire circle is going to represent the whole. Now, I have this broken down into little pieces talking about a circle graph. The circle graph is going to compare a part to a whole. A lot of times a circle graph is also known as a pie chart or a pie graph. So if you see circle graph, pie chart, pie graph, it's all the same thing. And to calculate the degrees of a piece, when we get to looking at our circle graphs, you're going to see that there's always an angle on the inside. And to do that, we need to calculate the part out of 360. So there might not be 360 parts, but we have to kind of turn it into 360 parts because a circle has 360 degrees around its central angle. And that's what we need to figure out how big each piece is. And that'll make a little more sense when we look at our next slides. And then all the percents, because in a circle graph, most of the time we turn things into percents, all of those have to add up to the whole, which is 100%. Now, let's take a look at some data that we have here. We want to figure out, can we use this data to create a circle graph? And if we can, why? And if we cannot, why not? So I look at this, and we have our t-shirts, and then we have the colors and the percentages of each. Now, if I look at this, if I add up 32, 19, and 6, does it add up to 100%? The answer is no. Therefore, we cannot use this to create a circle graph because the percents don't add up to 100. They have to add up to 100. Now, some might argue that maybe you throw in a separate piece that would be other colors to get that difference up to 100, and then possibly you could, but just based off the data that's in that table, we cannot make a circle graph. Now, in this one, what do we have to do before we start constructing a circle graph with this data? In this one, notice we don't have the percentages. This one, we have the actual number of different types of shoes, whether it's dress, sandals, or sneakers. So the first thing that we would have to do here is we have to figure out what is the measure of that central angle for each one of those. And remember, that's that part out of 360. So we'd have to turn that 17 into some measure out of 360 degrees. We're not going to worry about that part right now. I just wanted to point out what we'd have to do to first create that circle graph. Now, in this one, I have a few questions based off of this circle graph, and the different parts might be a little hard to see. The turtle is 15%, cat is 15%. I'll talk about those specific pieces when we need to in our questions. But we had 150 people in a county were surveyed about the kind of pet that they liked the best. And now I want to be able to pull information out of that by answering questions. So the first one asked, did more or less than 1/4 of the people surveyed like dogs the best? Well, I look at my circle graph, and I notice that everything is in percentages. It's not in terms of fractions. So I would look at this 1/4, and I'd say, well, what is 1/4 as a percent? If we take the 1 divided by 4, it turns out to be 0.25, which is 25%. So it's basically saying, did more or less than 25% of the people surveyed like dogs the best? Well, I come up here and I look at dogs. That's at 30%. So the answer would be more, because 30% of the people like dogs the best. Now, my next question asks, how many people liked cats the best? Now, notice it says, how many? How many people? So I want to know, did 10 people like? Did 20 people? I don't want to know the percent. I want to know how many. Well, I look at my cats up here, and cats are at 15%. 15% of what? Well, 15%, remember, there were 150 people surveyed. So we got to use this 15% and the 150 people to figure out how many actually liked cats. This goes back to our proportion. So I'm going to take that 15% to start off with. I'm going to turn it into a fraction instead of a percent. Remember, percents are always out of 100. So I have 15 out of 100. Now, I have a total of 150 people who took this survey. Well, the 150 people, that's our total, which would be like the 100, the total. But then what's in our numerator? Well, that would be the number of people who liked cats the best. We don't know that, so that's where I'm going to put a variable. I'm going to use C in this case. And we know that these two ratios have to be equal to each other. Now I have to solve my proportion. So in this proportion, I think it looks best to cross multiply, because I don't see a number that's going to I can't multiply 100 by something to get to 150, and if 15 doesn't go into 100 real nice, so I'm just going to cross multiply, and I find out that 100C equals, that's going to come out to be 2,250. So now I have to solve this equation. So the next thing I would do is I'm going to have to go through and I'm going to have to divide both sides by 100 to get the C all by itself. And then we find out that C equals 22.5, and then our label on that would be people. Now some would think, well, half a person couldn't have said they like cats the best. You're right. So what that tells me is that these percentages in our circle graph must have been rounded to the nearest whole number, because we can't have part of a person here. But that's okay. What fraction of people prefer fish or turtles? So now we got to come up here, we got to look at the fish and the turtles. So fish or turtles? Well, there's 25% of the population of the people surveyed like fish, and 15% like turtles. So if we want fish or turtles, we just need to add those two together. So 15 from the turtle, 25 from the fish, we end up with 40% of the people liked fish or turtles. And that's going to conclude my video on reading, interpreting circle graphs.